the sixth power of square root of 3 minus I. We'll solve the step by step using polar form and a Moivre's theorem. First, let's plot this complex number on an Argand diagram. Here's our complex plane. The point square root of 3 minus I has a real part of square root of 3 and an imaginary part of -1. To convert this to polar form, we need two things: the modulus r and the argument theta. The modulus r is the distance from the origin to our point. We can find this using the Pythagorean theorem. R equals the square root of the real part squared plus the imaginary part squared. That's the square root of 3 squared plus -1 squared, which equals 2. Next, let's find the argument theta. This is the angle our vector makes with the positive real axis. We can find this using the inverse tangent of the imaginary part over the real part. That's the inverse tangent of -1 over root 3. Since our point is in the fourth quadrant, this gives us -pi/6. Now we can write our complex number in polar form. It's our times cosine theta plus I sine theta, which is 2 times cosine of -pi/6 plus I sine of -pi/6. To find the sixth power, we can use de Moivre's theorem. This states that when we raise a complex number in polar form to a power n, the modulus is raised to that power, and the argument is multiplied by that power. Let's apply this to our problem. We get 2 to the sixth power times cosine of -6pi/6 plus I sine of -6pi/6. 2 to the sixth is 64, and -6pi/6 simplifies to -pi. Finally, we know that cosine of pi is -1, and sine of pi is 0. Therefore, the sixth power of square root of 3 minus I equals -64.